Here are going to be our first notes for Unit 6. Okay, this is going to be over parallel and perpendicular lines. So the definition of a parallel line is going to be lines that never intersect. Okay, if you look at these two right here, they will go on forever and ever and not intersect. Okay, it says algebraically, how do we know the two lines are parallel? That two lines are parallel. They are going to have the same slope. Okay, so for two things to be parallel, they have the same slope. So if I look at my example here, I know that slope is going to be what's in front of the x. So I have 2 and I have 2. They are the exact same slope. All right, I have a positive 2 and a positive 2. All right, lines that are perpendicular are going to be lines that intersect at 90-degree angles. Okay. If you look at this example right here, I could draw my little square to show that that is a 90-degree angle. Okay, those two lines will perfectly cross each other. Okay, and it'll give us a 90-degree angle when they cross. All right, so algebraically, how do we know if two lines are perpendicular? They're going to have negative, or opposite reciprocal slopes. All right, so if I look at the example on the side, okay, one slope is 2, just like the ones above, but now this second line, the slope is negative, and it is the reciprocal. Okay, so what that means is if I have 2 over 1 and I flip that, I now have 1 over 2. Okay, so if I have 2 over 1 and I flip that, I now have 1 over 2. All right, so it changes from positive to negative, and my numbers flip there. Okay, so it says, what are negative reciprocals? Well, that's what I just explained here. Okay, it is a fraction flipped and the signs are switched. All right, so if we look at this first example here, okay, this is a positive, all right? So I'm going to switch my sign, so it's going to become a negative, and then I've got to flip my fraction. So right now I have 3 over 4, okay? I've got to switch that, so I will now have 4 over 3. Okay, those are going to be the negative reciprocals. All right, so now look at number 2. I have 2, which I know is going to be over 1, okay, because I can always divide something by 1 and it won't change. Then I have a positive here, so it's going to become negative. I take my 2 over 1 and I switch it, which gives me 1 over 2. All right, you can finish example 3, 4, and 5, okay? You can check the teacher's journals to make sure you get these 3 correct. All right, here we go, moving on down. So, the bottom ones, 1 through 4, all right, it says determine if segments A, B, and C, D are parallel, perpendicular, or neither. Okay, so if I look at the first example, it gives me 2 points, all right? I can label these 2 points, x1, y1, x2, y2, because I've got to find the slope. All right, if I'm going to compare the slopes, I first have to find the slopes. All right, so if I look at AB here, all right, that's the one I just labeled. All right, I have this y2, which is 6, minus y1, which is 3. I have 2 minus a negative 2, which would change that positive you're given there. Okay, I would have 2 minus a negative 2, which would give you that positive. Okay, so now I look at the bottom part. All right, I have CD, which is formed by the point -1, 0. So I would label that x1, y1. And then I have 3, 3, which is x2 and y2. All right, I'm going to go ahead and circle these in the color they are. That way you know. All right, so now I write my slope. Okay, I have y2, which is 3, minus y1, which is 0. Then on bottom, I have x2, which is 3, minus a -1, okay, which gives me 3 plus 1. Whenever we do that, negative times a negative. So I'd plug that into my calculator and get 3/4, okay? These two are the same, therefore it is, if I go all the way up at the top, it's the same slope. I know they are parallel, okay? So my answer here is going to be parallel, all right? So let's go ahead and do, oops, I lost my place on here, okay? Let's go ahead and look at, let's go ahead and go with example 3, okay? We're also gonna go and do example 3. So for the top part, I have x1, y1, x2, and y2. So I plug it into my slope formula, okay? I'll go ahead and write that formula over here to the side for you, just so you can have it. Wouldn't be a bad idea to put on here for your notes, okay? So I have y2, which is 6, minus my y1, which is 8. All divided by, I have x2, which is 2, minus a negative 1. Okay? So if I look here, I have a negative times a negative, which gives me that positive. Okay, and then from there, I plug it into my calculator. I hit alpha y equals enter to get my fraction. Then on top, I have 6 minus 8, and on bottom, I have 2 plus 1. All right, I hit enter, and it ends up giving me negative 2/3. So my slope here is going to be negative 2/3. Okay, so let's go and work on line CD. Okay, so I have x1, y1, x2, and y2. So I plug in my y2, which is 3, minus, I have my y1, which is 2. Then on bottom, I have x2, which is 3, minus my x1, which is negative 1. Okay, that negative times a negative becomes a positive. So on top, I end up getting 3 minus 2, which just gives me a 1. And then on bottom, I get 3 plus 1, which is 1/4. So if I compare the two slopes that I got, I have negative 2/3 and 1/4. Okay, let's go back up to our rules real quick. In order to be parallel, they have to be the exact same slope. Well, if I look down here, those are clearly not the same slope. Okay, it's not the same numbers. So now let's see if it's perpendicular. In order to be perpendicular, they have to have the negative reciprocal. Okay, so that means the sign has to change, has to switch, and the fraction has to be flipped. Okay, if I go and look at my example down here, the sign did change, but the fraction did not flip. Okay, so this is not parallel and it is not perpendicular, so the answer here is going to be neither. Okay, so on this front part, you can go ahead and work out 2, 4. All right, on that first page, you can work out 3, 4, 5, and then down here, 2 and 4. Okay, all 5 of those problems on this first page. All right, now let's go ahead and look at the second page of these notes. So at the top, once again, you can do these ones. So 5, 6, 7, and 8, I'm going to leave for you to do. All right, those are parallel, perpendicular, or neither. Okay, and then we'll go ahead and look at the bottom part here. Okay, now it's given equations. All right, I've got to figure out if these are parallel or perpendicular. Okay, I need to scroll down some, sorry. Do apologize. Okay, so what we did here is we wrote down the slope. What's in front of x here is 7. What's in front of x here is 7. So the slope is the same, which means it's parallel. Okay, so now let's go ahead and look at number 10. Okay, I have 4/5. So my slope here is 4/5. And then my slope here is going to be negative 5/4. Okay, I know it's not parallel because those are not the same, but for perpendicular, okay, I know it is a fraction that's flipped and the signs are switched. So if I look here, I have 4/5 and it switches. Here I have 5/4, so we're good on that. Then the second part of it is the signs have to switch. This is a positive and changes to a negative, okay? So the fraction's flipped and the signs are switched. That means that the answer to this one is going to be perpendicular. Perpendicular there, okay? I will let you do number 11. All right, and then if we look at number 12, okay, if I look here, I'm given x and y on the same side. That means this is in standard form, okay? So this is in standard form, so I've got to get y all by itself. So first, you've got to move that x away from that y. So we subtracted x on each side, so minus x and minus x. Those canceled out. So on the left-hand side, you get 6y left equals, I have 30 minus x, all right? Then from there, in order to get rid of that 6 that's multiplied by that y, I have to divide everything by 6. All right, so those would end up canceling out there. I'm left with y equals, I get y equals 30 divided by 6 is 5, and then I just get 1/6 x over here. Okay, I have a negative 1 in front of that x. All right, so I get negative 1/6 x. All right, so I look at this. Okay, the number in front of my x is my slope, so my slope is negative 1/6. Then over here, okay, if you just look, I have 3 times y. That means I have to divide everything by 3. All right, when I divide everything by 3, those cancel. So I get y equals 18x divided by 3 is 6x, and then negative 6 divided by 3 gives me that negative 2. So my slope in front of that x is 6. So my sign changes. I go from negative to positive, and my 1/6 flips, and so it is now 6/1. So so both rules apply. The fractions flipped and the signs switched, so it is a perpendicular set of lines there. Okay, so I think I'm going to go ahead and look at, let's go ahead and talk about 15, just because it's a little bit tricky. Okay, looking at number 12, 13 and 14, you're going to have to work those out a little bit like number 12, all right? So if I look at number 15, all right, it looks pretty simple, but we've got to be careful with these ones. So my slope here is what's in front of x, which is going to be 1. So I get m equals 1, all right? When I do slope, though, remember, you can always divide it by 1, all right? That's how I get my rise over run. So really, what's in front of that x is 1/1. Now, if I look at this piece right here, I have negative x, which means my number in front of that is that hidden 1 that's in front of that x, all right? It's not the imaginary one, but it's what's hidden in front of that x there, all right? So I have that negative 1, all right? And then I know I can divide by 1, okay? So this one might look a little tricky, but if I think of my 2 rules, okay? First of all, for parallel, they're not the same slope. This one's negative, this one's not, so I know it can't be parallel. But if I think of my perpendicular rules, okay, the first rule is that the fraction is flipped. Well, if I have 1/1 and I flip that, it is still 1/1, okay? So that rule would apply. Then the second rule tells me the signs are switched. So this one goes from positive to negative. So both rules work here. All right, so my answer is going to be perpendicular. All right, one thing I like about number 16, okay, is we've got 2 different kinds of lines. All right, we talked about these previously in class, but we haven't looked at them since then. So I know that if we're talking about y equals 6, okay, I'll show you on the calculator real quick. If I'm talking about y equals 6, I know that that is going to be a horizontal line, okay? So y equals 6 is going to be a horizontal line. If I'm talking about x equals -1, I know that's going to be a vertical line at -1, all right? So let's go ahead and talk about the slope, though, since that's what we are doing here, all right? So if I'm talking about y equals 6, I know that is a horizontal line. Okay? Whenever I have a horizontal line and we think about slope, dude, that is 0 fun, which means our slope is going to be 0. Okay? Y equals 6 is that horizontal line, so my slope is going to be 0, according to slope, dude. If I think about a vertical line, okay, because at x equals -1, at -1, that's where my line would go up and down. If I think of a vertical line and I think of slope dude tells me that my slope is going to be undefined. Okay, so I have a 0 slope and undefined slope. So if I was to cross those, all right, I'll go ahead and show you on here. If I was to cross those, okay, I would once again get that 90-degree angle. So this is perpendicular. All right. That zero slope and undefined line make a cross there, therefore it is perpendicular. All right. So go ahead and finish this page. You have 5 through 8 and then 11 through 14 there. Okay, so you've got 7 problems on the second page you can work through. Okay, and if you do look on this left hand side, there are a couple of steps for you when you're working out 12, 13, and 14. So solving from standard form to slope-intercept form, it gives you the forms right there. You're going to add or subtract the mx to the other side, which is what we did with that x there, and then we're going to divide by the number that is in front of y. Okay, so that number in front of y is 6, so I'm going to divide it to get away or off of that 6 there, or off of that y there. Sorry, I said that wrong. All right, so that is your parallel lines notes. Okay, the next thing that you need to work on, all right, is I have this parallel, perpendicular, or neither worksheet. Okay, if you look, here are 2 equations given here. Okay, you need to show your work here. So for this particular problem, okay, my first slope, okay, and I'll show this one in orange. So I have m equals 3. Okay, the second one, I will show it in purple. I have m equals 3. Okay, so they're the same slope. So same slope, which means that they are parallel. I just spelled parallel wrong. There we go. So same slope, so they're parallel. So you'll do your work for 2 here, work for 3 here. Keep going. I have 4, 5, and 6. 7 is a little tricky. You do your work down here. And then 8, you do your work right here. On 9 and 10, okay, that's kind of the example that we did right here on number 16. So 9 and 10, you don't really have to show your work on. Just think about it, okay? It's very similar to number 16. So just kind of think about numbers 9 and 10, all right? That is the end of your parallel, perpendicular, or neither notes.